Welcome back, everyone. We are going to continue looking at different strategies to solve problems involving geometric sequences. Let's have a look at the next example together. So, guys, we have been given the geometric sequence 4x minus 3, x, 2x minus 5. Just something that I want to highlight right at the beginning is I've been told that it is a geometric sequence. So when I've been told that it is a geometric sequence, I know that there has to be a common ratio involved because we know that is the main property of a geometric sequence. So we need to now determine the values of x for which these terms form a geometric sequence or geometric sequences. Then B is asking me to determine the formula for the nth term of each sequence. So the question has kind of also given me a clue that there's going to be more than one value of x. Let's try and work out x together. So we have the first three terms, and I've been told that it is a geometric sequence. On the slide before, I mentioned to you guys that we know that the geometric sequence property is the fact that there is a common ratio. I'm going to use the fact that there actually is a common ratio in order to solve for x. How can I do that? I know that the common ratio is equal to term 2 over term 1, but I also know I can write the common ratio is equal to term 3 over term 2. Now, if you're wondering, how is this going to help me? This is going to help me because I'm going to end up with two different expressions for the ratio that involve x's, but I know that the common ratio of a geometric sequence is the common ratio. It's called the common ratio because it's common. So that means that I can equate them because they have to be equal, because I know the ratio is in fact common. Being able to equate them means that I can actually solve for x. So let's solve for x together. So I'm going to substitute in term 2 over term 1, which is going to give me x over 4x minus 3. Then I'm going to substitute in term 3 over term 2, which is 2x minus 5 over x. As I mentioned, the ratios are common, so I can equate these two expressions to each other. So I know that x over 4x minus 3 has to be equal to 2x minus 5 over x. I'm going to do some cross multiplication over here in order to solve for x. So I'm going to have x squared is equal to 2x minus 5 times 4x minus 3, which means I'm going to have x squared is equal to, if we do FOIL or however else you know how to multiply binomials together, you're going to end up with 8x squared minus 20x minus 6x plus 15. Then what I'm going to do is I'm going to take this x squared over to the right-hand side. So I'm going to have 0 is equal to 7x squared minus 26x plus 15. Great, so now we are going to actually factorize to see what the values of x are going to be. What I need to do is I need to know what 7 times 15 is. And I need to use those factors to create negative 26. So let's see what happens when I divide. Oh, let's have a look. So that means that x will be equal to 5 over 7, or x will be equal to 3. Wonderful, everyone. So far I have done A, I have solved for x. Now I'm going to look at the second part of this question, knowing that I actually have two x values. Let's look at the next slide together. So I know that my two x values are x is equal to 3 and x is equal to 5 over 7. The question for B is asking me to determine the formula for the nth term of each sequence. And I'm only going to be able to determine the nth term for each sequence by actually substituting in the respective x values, as substituting in the respective x values will actually be able to help me find A and R. So for each case, I'm going to substitute in x is equal to 3 for the pattern. So I'm going to have 4 times 3 minus 3 for term 1. I know that 3 will be the value of term 2, and 2 times 3 minus 5 will be the third term of the pattern. I'm going to do the exact same thing for when x is 5 over 7. I'm going to have 4 times 5 over 7 minus 3. For term 2, I know that it will have a value of 5 over 7. Then for term 3, I'm going to have 2 times 5 over 7 minus 5. So all that I've done is I've substituted in the respective x values to find the first 3 terms of the patterns. I'm going to ask you guys to do that for yourselves, and you should get that when x is 5 over 7, the pattern goes negative a seventh, then 5 over 7, then negative 25 over 7. Then when x is 3, we should have the pattern going 9, 3, then 1. Just a reminder, I'm looking for the nth term of these patterns. So I want to write these patterns in terms of Tn is equal to A to R to the power of n minus 1. So for when x is 5 over 7, I can see that A is equal to negative a seventh. R is actually equal to negative 5. Because I can see that between each of these terms, there's been a multiplication of negative 5. So you can use the R formula in order to do that and check it. I have time constraints, so I am going to continue. So Tn will be equal to negative a seventh times negative 5 to the power of n minus 1. Looking at the example when x is 3, I can see that A is equal to 9. My common ratio is going to be a third. Why, you may ask, is because between each term I've multiplied by a third, and multiplying by a third is actually the exact same thing as dividing by 3. So Tn will be equal to n, or A, which is 9, times a third to the power of n minus 1. So that's the end of that question, everybody. We're now going to look at the next example. The next example is going to require your knowledge of arithmetic sequences as well as geometric sequences. I'm going to ask you to remind yourself that an arithmetic sequence has a common difference and a geometric sequence has a common ratio. We're going to use both of these pieces of information to solve this question. Let's have a look at the question together. So the first 3 terms of the sequence 6xy 16 form an arithmetic progression, and the last 3 terms form a geometric progression. So A is asking me to first determine the values of x and y. B is asking me to state the arithmetic and geometric sequence for each of these solutions. So please remember the first 3 terms are arithmetic, so that's your common difference. The last 3 terms are geometric, which means it's going to be a common ratio. Please note I've just wrote CD for shorthand for common difference and CR for common ratio shorthand. So we need to determine x and y. These 3 are arithmetic and the last 3 are geometric. And the fact that I have an x and a y means that I'm going to be doing some simultaneous solving. So, everyone, an arithmetic sequence has common difference as its main property, and geometric sequence has common ratio as its property. We are going to then create expressions involving x and y using the fact that it's an arithmetic combined with a geometric sequence in order to solve for x and y. I'm going to go through it step by step. Please just stay with me. I know it's a lot, but you've got this. So, we know that these 3 will have a common difference. So we know that term 2 minus term 1 will be equal to term 3 minus term 2, because we know that the common differences of an arithmetic sequence are equal to each other. So that means that x minus 6 will be equal to y minus x. Immediately what I'm going to do is I'm going to isolate y by taking this negative x over. So I'm going to have that 2x minus 6 is equal to y. Then using my knowledge about geometric sequences, I know that if this is term 2, term 3, and term 4, term 3 over term 2 will be equal to term 4 over term 3. So y over x will be equal to 16 over y. I'm going to do some cross multiplication so I can see that y squared will be equal to 16x. I'm now going to take this 2x over, or the y over rather. Let me just erase that, everyone. Great, guys. So now I'm going to take this y across. So I'm going to have 2x minus 6 squared is equal to 16x. If I multiply those two binomials out, I'm going to be left with 4x squared minus 24x plus 36 is equal to 16x. I'm now going to move the 16x over to the left-hand side, so I'm going to have 4x squared minus 40x plus 36. To make this trinomial a bit easier, everyone, I'm going to divide by 4, so I'm going to have x squared minus 10x plus 9. This trinomial can be factorized to be x minus 9, x minus 1. So x is equal to 9, or x is equal to 1. And I just need to find the corresponding y values. So when x is equal to 9, I'm going to have 2 times 9 minus 6 is equal to y. So that means that 12 will be equal to y. Then when x is equal to 1, I'm going to have 2 times 1 minus 6 is equal to y, which means I'm going to have negative 4 is equal to y. So we've got the two pairs. X is equal to 9 goes with 12 is equal to y, and x is equal to 1 goes with negative 4 is equal to y. So we are now going to write down the individual sequences. We have the arithmetic sequences, which are the first 3 terms, so it's going to be 6. Then using the first option, it's going to go 6, 1, negative 4. Using the second option, it's going to be 6, 9, 12. Just remember, I'm substituting in x and y. The geometric sequences are the last 3, so this is going to be 1, negative 4, then 16. Then using 9 and 12, it's going to be 9, 12, 16. Great, thank you so much for joining me today, everyone. I hope that geometric sequences are making more sense, but I look forward to seeing you next time. I hope you have a great day.